Great. So today is a bunch of high-level testing tips. Now, I went through these, and I recognize some of them appeared in, not surprisingly, kind of the best practices, greatest hits that I did in the first 3 days of the course, or what have you. And those are designed to be repeated, so I don't regret repeating them. But I'll go over them fairly quickly rather than dwelling a lot on them, and try to get to quite a few slides here that are entirely new. The goal here is to sort of give a few operational suggestions for testing effectively, and to try to impart some basic concepts that will be useful for discussing risks. So much of testing is basically about risk management. We have basically, it's almost impossible in any realistic system to test it exhaustively. It's just not going to happen. You're not going to get nearly exhaustive testing. All possible inputs in all combinations, it's not going to happen. So it's about taking your time and prioritizing it, really. It's about triage. It's about how do we use our limited time to test most effectively. And some of you are exploring this already with spike prototypes, for example, exploring technical risks, possible vulnerabilities, things which might not come together. You're trying to explore how to address them. Will it be handled by this technology properly, or what have you? Maybe it's compatibility between certain hardware and certain libraries, or what have you. And many of you are dealing with a end-to-end system, which is fairly involved. It's not just the user interface that matters, but the admin interface. So it's not just the people entering, the safety reports, but it's also the people reviewing them on the back side. Possibly it could be an interface for adding in users who can browse these reports. And so there's often an admin side that the user's not thinking about, but we as technical people need to be thinking about. There's issues of data backhaul. How does the data get to the server? How does it get exported for further analysis, or what have you? What databases are used, etc. And when you think about testing, you should be thinking about testing these various components, not just the user experience. Something I'll come back to with hallway testing is this need for testing with non-CS users outside the stakeholder. Many of you are friends. You're on campus, family members in town, what have you, where you can do some testing with them. And for reasons we'll talk about, this can be very useful. You might think that CS people are more rigorous testers, and in a certain respect they are, with respect to stress testing, perhaps load testing, systematic testing. But it turns out non-CS people are even better at finding certain types of problems, because they're not blinded by our assumptions that we have as computer scientists. And the need for ongoing risk scanning. Okay, so some suggestions. I'm going to whip through these because some of them you will have seen previously. One of the most important, though, it's hard to imagine repeating it enough or too much within this term, is when you're debugging, when you are finding problems and removing them, you need to be thinking about removing not just problems in the code base, but problems in the process. What allowed this to get in there in the first place? What was it that meant that this bug got introduced? And how did it evade us thus far? What was it about our peer review of this code that didn't catch it? What is it about our testing that let it slip through? What is it about our requirements or design document that let this happen? How can we improve it next time? It's not a matter of, just dwelling on the negative side. It's about how can we do better next time? What can we do that would help prevent this from coming up? And you need to think about it like that. It's not a witch hunt. It's about how can we learn from this so that we're even better off having found this bug. Test-driven development is something I've requested. So you make the test, make it run, and then make it right. So you're making the test, you make it run. Initially, the tests will fail. You make the code, and it is going to pass the test, and you may do refactoring as well. I think all of you are using a bug tracking system. You know, anything from Redmine to Jira to Bugzilla to GitHub's bug tracking systems are good. Without that, you're not quite flying blind, but it's really difficult. Things fall through the cracks big time. We talked about testability. I won't be going into that more. When you have tests that find bugs, particularly tests that look effective, automate them. Try to automate them. Try to create a script to perform them. As we'll talk about, regressions are a big problem, and these can help catch regressions. Cases where a bug comes back, for example, or something that was working no longer works. This is something you really need to do. There was a team, I can't remember if I've told you, I don't remember doing it. What's that?
The IBM black team?
No, the black team at IBM was famed for the ability to crush code, find errors quickly. You know, they'd like to do it in front of the author often. And I can break it. I can break it in 30 seconds. Which I'm not sure I'd advocate that as an approach, particularly for, you know, in today's environments. I don't think it would be appropriate, but it shows something about prowess. No, test errors is actually about the opposite of the black team, the black ops group. This checking test errors is about a team that aspired some years ago to a project of significance to some of you. How many people here are involved with CSSS? Say it ain't so. Okay, well, hopefully that's not because of their problems. So their job, the dream that fired them up, was to create software for the CSSS executive to loan books, keep track of the books that were out, to rent locker spaces over in Sphinx, to maintain other information, I think, about accounts and so on, the sort of monetary expenditures, etc. So this dream fired their blood, and they aspired to create software to support this, and they did create some software. And part of the requirements, then as now, was that they had to test it and demonstrate thorough testing. So they gave me these test reports, which indicated systematically across a set of tests, it was 3 thumbs up for these tests. I don't know what the third one is, it was big toe or something. But 3 thumbs up, pass these tests, right? Test after test after test. And then I actually looked at, they actually had some test logs that I could access. And I looked at those, and what I found is that basically the test results were bogus because the system hadn't even been able to log in. And so it wasn't even getting past the login screen. It was just showing that the test had run. But never was there a check that, it actually gave desirable results. And of course, that's the whole point of a test, an automated test, is does it pass or not? Did it achieve, the correct output from the system or not? And their test had just given 3 thumbs up because it had run. And that sort of testing offers limited value. In fact, I would argue it offers negative value. Negative because it fools you into complacency, thinking, oh, this is working, where it's really not. It just didn't enter the password properly or something, so it got stuck. 3 thumbs up. I remember it well. Thumbs up. So check your test errors, have them log, have them output to a database, indicate basically which succeed and which fail. Now, I'll tell you this. If you give me test logs, you give me test results, which indicate that you're running a lot of tests and a lot of them are failing, I'll view that as good, because it's an indication that basically you're measuring the things that matter. It helps you focus your efforts, you know, where it's broken and so on. That's nothing but a good thing as far as I'm concerned, because it lets you move forward. As we say, fall forward, fail forward. But if you're not checking the test errors, if you're not reporting on what the test results are, you're missing something big. This sounds very basic, but it was basic for them too. And they didn't do it in the first round. Incidentally, I think their system, by the end of the semester, I think they had gotten the book loaning functionality working. And they were just getting the locker functionality. I think you could rent a locker, but you couldn't relinquish it or something like that. So they didn't end up getting very, very far. 3 thumbs up. Okay. To go in to things here. Okay, buddy testing and pair testing. Anyone know the difference between these two? It's actually a significant difference. Amongst other things, often pair testing is done by testers. It's like pair programming, but for testing. 2 people sit next to each other. They each have ideas about what to do next, talk to each other about their observations. One might notice the other things, the other doesn't. And one of the odd things about pair programming, as well as pair testing, is you can take an expert together with a neophyte, someone who's very new, and actually you find the expert benefiting from the presence of the neophyte. Clarity of comments, clarity of thinking about what's happening, just noticing things, and it's maybe even more so with testing than it is with development. Buddy testing, by contrast, is where you have two developers. Pair testing is generally with testers. Buddy testing, 2 developers, one tests the code of the other. Each tests the code of the other. So I test my buddy's code and they test mine. Okay? Why would that help? Why does it help to have people test other people's code?
They come at this from a new perspective.
New perspective, and they're not blinded by the same assumptions necessarily. So when I read, the documentation, the specification, or get a description of what this is supposed to do, I may come away with one understanding, whereas this other person doesn't. Builds require the code be tested against a smoke test before check-in. The smoke test should only run on the server. It should actually be run first locally. Why is that? Why not just let the smoke test run on the server? Why test it on your own machine before uploading it to the server? Why do a smoke test on your machine before the server?
To make sure it never gets uploaded to the server.
Yeah, it's a lot bigger of a deal if it has to be rolled back after a check-in at the server side. It will be a black mark in the sense that it will indicate that the build failed. So it's much better if you do it locally, and it's not typically hard to do. Many of you wanted to do unit testing against at least the local ones. Big issue, I've mentioned it before, I'll mention it again. Ladies and gentlemen, systems in the world, human or physical or IT, they tend to fail not at arbitrary points so much as at boundaries. Boundaries, ladies and gentlemen, between subsystems. And one of the biggest boundaries where failure can occur within a software development project is between the developers and the testers. And that is the point of greatest weaknesses on a lot of your projects. Often they're not working effectively. When I say effectively together, I include things like the testers don't give the developers don't give the testers code until the last minute, or the testers don't really communicate or discuss their testing plan with the developers. and they're working at cross purposes or just totally discoordinated. I remember some years back we had a testing team. They created this wonderful testing plan, but it was just out in outer space. I mean, it had very little to do with the code base. It wasn't dealing with the actual code base. They weren't talking with the developers about what's in place. So they spun this kind of idea of what they were going to test, but it was hard to realize because they were testing features that might not be in the system or might not be planned after all. It was a difficult thing. Defect tracking system. I don't think I'm going to dwell on this. These are quite central. You want to make sure bugs aren't just circulating between people that actually get dealt with. Okay. One of the biggest things you got to watch out for is skipping tests on late check-ins. The things that are last minute are the things that most need testing. Why is that?
They're usually done in a hurry.
They're done in a hurry. They're rushed out. Sometimes the person doesn't test them themselves before uploading them. You want to test them because they're among the most buggy things. For those in 394 last term, I mean, from a systems perspective, often we're trying to manage complex systems, and we end up, because negative feedback, things that stabilize it, things like testing, peer review, risk management, time off for developers, and so on. Those are things which require some investment of resources. They're the things that get cut. But those are associated with the balancing feedbacks, the things that keep the system stable. And when those are cut, whether it's getting people to work huge hours or getting them to skimp on testing, that's where things can often go way out of whack, because the system is losing its regulatory capacity to kind of keep itself in balance. And one of the ways is skipping tests. Another one is basically suspending risk management or suspending peer review, saying we don't have time to do peer reviews. In many cases, you don't have time not to do peer reviews. They're going to find the bugs that are going to otherwise cause the fires that are going to make you seem like you don't have time for peer reviews. So it's like too busy bailing to plug a hole in a boat. It's not too effective. The boat's going to sink. You just sit all your time bailing instead of dealing with the underlying problem, you're going to be in trouble. Anyway, a bit of 394 sort of systems thinking there. Plan for non-functional tests. You should have some sort of plans. I think all of your systems should have some sort of plans, the three projects, for doing testing, which the developer, the stakeholders are not going to request, but it may be important. These include stress testing, load testing. So testing the system with large numbers of users, or testing it under computational load, doing some performance tests on it, for example. I'm not saying you have to do all, but think about doing tests that have to do with the performance or memory footprint or ability of the system to handle load. I think some of you, like the ones with the Oculus, they're to avoid motion sickness, to make sure that you have suitably high frame rate or what have you. This would fall into that category, right? Isolate test development environment. You should be performing a lot of manual exploratory tests. You want to, but don't do them totally random. Try to have a goal in mind to systematically explore the system. I've never tested this before. I've never tested that feature. Let me go do that. That's a good strategy. Otherwise, if you notice flakiness in certain areas, this is very valuable stuff. Manual tests. If you find a bug, try to automate it. Try to automate the test so you can do it in the future. So automating regression tests. Try to do a code freeze several days before shipping. Why would you do that? Prior to the deliverable. 4 days, 3 days before testing. Why freeze the code?
So it is adequate time to go through testing and quality assurance.
Yeah, exactly. Because without that, realistically, you're probably not going to have time to test it well. Or if you do test it, you're not going to have time to fix the issues that come up. But even more directly, ladies and gentlemen, if you don't do this, the testing team is going to be horribly underperforming or undervalued through no fault of their own, because they just don't have the code. So they're going to be eager to test, able to test, and they don't have the code base, which is going to basically mean a lot of the members of the team's time and work is going to not come to a lot because they don't have the code. So freezing early, trying to freeze early, even if it means a feature or two not making it, I would strongly encourage. If you tell me, look, we couldn't include these two features because we ended up doing a code freeze, 4 days before, I'll say, good call in most cases, because that's what allows your team to get quality product out. Remember, ladies and gentlemen, if a bug is found late in the game, like 1 day before, half a day before, often you just don't have time to do a serious fix, retest, confirmation that it's working. And that's dangerous. That's a dangerous situation. To do be unable to do a thorough set of tests. Okay, test environments. You're going to want to think about distinct test environments. Those are operating off of phones. Maybe you folks here have upper end phones for iPhone or Android. But you're going to want to test it on some devices which are not nearly as good. If you're working on desktop systems, doing it with no admin access. This is a big bane in Windows land. I don't know how many of you have done serious development in Windows, but one of the big problems is that a lot of Windows users run as admin. They have admin privileges. And what this means is that when you're developing the code, certain bugs don't show up, that when you go to deploy to a standard user who's not admin, they can't even run it. All these problems come up, all these problems with permissions. So, for test environments, generally you want it to be a lower end machine, no admin access, limited computational resources associated with it, and potentially to configure it in several different ways. Don't just assume that a user's machine or hardware or what have you is going to be similar to your own. Or if it is, make sure it's documented, that requirement. Similarly with screen size. Quite a few people in the room may have smartphones with larger screens, phablets or what have you. And that's all well and good, but I've released product where we have a product works great on those size screens, but when we see the diversity of Android devices out there with small screens, it starts to look pretty poor. And it starts to be confusing because things aren't positioned right, and you can't see a button that's really there, etc. It's bad news. People have to scroll up and down rather than seeing it all on one screen. So try it with a diversity of devices. More of an issue with Android than iPhone. iPhone is more standardized around a small number of models. Android, it's like 1,000 flowers bloom. There's tiny Android devices, etc. So see if you can get a hold of some of those. Don't assume obvious bugs have been previously reported. If you get a failure early on, don't assume that it's known. Try to find out. Use your Slack channel or whatever to check. Quickly report defects. We'll be talking quite a bit about boundary cases, test design, and one of the big goals of it is to find cases that are likely to be areas where bugs might creep in, particularly what we call corner or boundary cases. Cases where you ask someone their income and it's 0, or you ask their age and it's above 100, or whatever. These cases that you may not have been thinking about. Someone whose name has one name. I know several people in my life I've met. They have one name. First, last name, or there's no separate first and last name. They have a single name. And, you know, it may not be a case that you've handled. Names with apostrophes in them may not be a case you've handled, etc. So you're going to be wanting to think about sort of unusual cases that you may not have thought of, right? Report non-reproducible errors. Add them with the note that you haven't been able to reproduce it, but say something about what was going on when this was happening. Because if enough people say this and there's some commonality noted, it could be useful. And choose the subject line for the system trouble incident reports carefully. So make it meaningful when people see the name, the title, they get some understanding of what it is. Quickly check bug fixes. If there's a bug fix pushed out, try to check testing team that it's actually fixed it. And in many cases, we automate tests via interface. As we say, we program against the interface. What does this mean? What does it mean to program against an interface? Anyone? We have a class C here, also Java. Okay. Similar things, Objective C, I think. Here's a class C. Beyond classes, what do we have? This can implement a what? Begins with an I. Interface, thank you. This is an interface. This implements that interface, right? Why do we, and then we have implements that interface. And then we have users of C writing their code against this interface. Why write it against the interface? Why not just manipulate known instances of C?
Gives another level of abstraction.
Yes, it gives another level of abstraction, and when we have abstraction, we have flexibility and generality. What flexibility? And often lower vulnerability to change. Where does that come in concrete terms? Why does this help?
We want to hide a lot of details.
We're hiding details
And
about.
the other methods as well.
Good. We're hiding details about what? Which class we're using. This is C1. And we might later instead substitute, instead of C1, we actually end up substituting C2 here. Maybe C2 is a mock of C1. Maybe it's a fake version of C1. Maybe it's not a fake version, but it's a it's a newer version. It's one that that has been overhauled at some level or what have you. But the point is, going against the interface, having these things going against the interface means that you can more easily evolve this and you can more easily mock it because you're just counting on a subset of the total functionality. You're not hardwiring the dependence on C1. And we have things that are called factory methods or factory objects that basically allow us to get an instance of an object as an instance of an interface rather than as a specific instance of a specific class, a named class. So programming against interfaces is a best practice to enable flexibility. And one of the things that it allows us to do is to allow us to evolve things here, okay? So automate tests via interfaces. Incidentally, you could provide, how many, in Java, a given class can extend, that is can subclass, how many classes? Yeah, at most one. One class. How many interfaces can it implement?
Theoretically infinite.
Yeah, it's unbounded. Unbounded number of interfaces. So, among other things, these could implement a testing interface. Implements some test interface, right? Which aids with testability. It has hooks in it, it has things to sort of check internal state or whatever. It can actually implement several different interfaces. A test interface might be used for testing related code. This might be used for production code, etc. So here, this is another aspect of flexibility. You could have implementation of different interfaces for different purposes, where that one's used, for testing, the test interface. So this is good. So testers and end users should close bug reports rather than the developers themselves. The final resolution should be those in the test team or those who report, not developers. Developers can say it's fixed, but it needs to be tested for it to be fully closed and resolved. So the overall workflow is, there's programming team is releasing, this is from Rex Black's book on critical testing processes. They're releasing bug fixes, and some of those are released to the testers, and the testers will then do confirmatory testing. When I say confirmatory testing, give me a big example of a confirmatory test. Begins with an S. Smoke test. It's a confirmatory test. It's kind of a clear one. And then there might be scheduled manual and automated testing, and then some exploratory testing. So exploratory testing is manual testing. It's designed to try this out. Let's see where some additional bugs might be. This area looks a bit soft, etc. And an important thing here is you might or might not want to push. And generally I'd say probably don't push every build, every continuous integration build to the test team. It might not be every build. It might be builds, once a significant number of added features get done. Those builds are going to be going on. It's just you might want to be cautious about deploying them to test infrastructure and so, etc. That might be done only for higher quality types of builds. Okay. Okay. Testing tools. This is, I think, also from Rex Black's. No. This is, I think it's effective testing by Destin. I had a reference to it earlier. I think I'll have to get that in here. Test procedure generators, test coverage analyzers. Some of you are using this. Memory leak detection, usability measurement tools. How much people are using different features might sometimes be useful. There's things that run metrics on source code to sort of report how many lines of code there are per method, or how much coupling there is between methods. Generating test data, network testing tools and GUI testing tools, performance and load and stress testing tools that will sort of have many users go to this website or put in place stress in the form of low memory conditions or what have you. There's lots of test tools out there. This is an older list. There's, I think, even more now. Try to find out about some of them. Try to use some of them. I was really happy to see some people doing code coverage this last time. That's great. That warms my heart to see you doing test coverage. That's great stuff. But see if you can use a few additional types in coming deliverables. Okay. So testing is all about risk management under limited resources. There's opportunity cost. If you test one set of things, it probably means you're taking time away from testing another. So you got to balance and prioritize. You want to look for the things that are high gain. So these are some elements that are enumerated by Dustin's book on effective testing. Really great book, by the way. Really recommend it. I think it's called 50 Concrete Ways to Improve the Effectiveness of Your Tests. Good stuff. There's a book by Gaskill also on testing, which I think is pretty good. So these are some things to watch out for. Code that was checked in late. We talked about that. New design. High complexity of the code. It's a gnarly algorithm. Newly implemented features. the people who wrote this were still learning Swift. It's known to have sort of rush coding associated with it or shaky design. It was created in a fatigued time, like just before the last deliverable was due, the night before, and you know that the people who created it were working long hours, etc. Past bugginess. This area has been seen to be buggy in the past. These are some good reasons why there might be issues with particular areas of the code. So see if you can focus some extra testing on these sort of things. So I mentioned buddy testing here. It can lead to sort of less sympathetic testing. Bug parties. I mentioned this some weeks ago when someone had asked about it at the time. The idea here is to do ad hoc testing. By ad hoc, I mean manual testing. Manual testing. I don't mean flailing at it, but I mean like you're jointly doing manual testing. Maybe some people are doing it against the administrative interface to examine the incidents that have come in, others against the phone, others checking the connectivity between them, what have you. But basically you're going at the software to try to find bugs, improve inventory of bugs, and improve test coverage. It's a lot of fun. Teams that do this tend to find it really enjoyable, but it does take time. So you want to set aside 2 to 3 hours for this, and sometimes people get rewarded for finding the most bugs or the biggest bugs. People who can get it to crash, or they get some sort of reward. And from this, you can create actual test cases that test these things. Now, as we'll see, probably after the break, there's another reason you do bug parties. And the best opportunities here, this may sound counterintuitive, the best things is to do 2 bug parties at the same time. Same night, same time. Maybe you have half your group in one and roughly half in the other. Maybe you have 6 and 6 people or whatever. You do bug parties. Why would that be useful to do them at the same time?
See how much overlap there is.
See how much overlap. Suppose there's a huge amount of overlap in the bugs found. What does that suggest?
Found most of them.
You may have found most of them. Suppose there's almost no overlap. This group has found 30, that group has found 30, and there's only 1 or 2 they overlap.
Chances are there's still a lot left.
Yeah, there's a lot of bugs out there probably. There's a lot more to be found. So if you do simultaneous bug parties, it'll give you a sense of how many undiagnosed defects are out there, which may sound counterintuitive, but it's a very practical thing. You can get a sense of how many defects might be out there that we don't know about. Gives you a sense of what we don't know about yet. Hallway usability testing. The idea here is basically drag in non-CS users to do some testing. Most of you know some family members, people around here. Just bring them in and do testing. Why would this be useful? We might think of ourselves as more rigorous in our ability to crush software, but why is this useful? I'm not saying these are the only ones, by no means. There's actually a lot of testing that we as software engineers, computer scientists can do better. But why is it so critical to get these folks?
You can test how easily your apps are to use.
Okay, so usability, that's a big thing. Another voice?
Oh, it's just that, you're building your software for somebody, and
Yeah.
you need to test against those users because
Good.
you're developing and you make assumptions that they don't, and often you make assumptions about even
Yeah.
their expertise. Like,
That's right.
like my dad can't touch type, or even he doesn't know.
Yep.
Like you click the little X in the top
Yeah.
right-hand corner to close it, right? Like some people aren't familiar with that stuff, and we
That's
forget
right.
that.
Yeah, I remember I was running my first company that I helped found, and this was 20 plus years ago now. And we had it was a little bit of a promotion event. We had several clients who were extremely happy with our system, and so this was back in the 90s, and we basically did, so this must have been like 97, 98. We did, in the opening years of the internet, there were these chat rooms that you could go to, and we had this chat room set up, and people could basically come ask questions or interact online. That was very, very cutting edge at the time. You know, you could interact with these people online. So we had this person, he was I think a vice president of a big name university in the States. And so we brought him in to answer questions. He was going to be talking about our software and how it had revolutionized their way of thinking about things. And he sat down and was all eager to get started. And the questions started to come in. And so he was going to respond to them. The problem is he was sheepish to tell us, but he didn't know how to type. He couldn't type. And so, you know, he started to type responses, and he was hunting and pecking. It was very painful, because these questions were coming in, and, you know, he had to respond. And so, you know, we ended up scrambling to get someone to type for him, and he could just, you know, dictate or what have you. But that was a whole era. That was a whole era. And if you go over, not far from my office, the men and women's room over in Thorvaldsen, you'll see a picture of one of the first computers at the U of S campus. And you'll see a bunch of professors hunched over a terminal together with a young woman. And the young woman is doing all the typing, because that was considered at the time sort of a skill for secretaries. And it was actually a skill that a lot of people didn't want to learn, because it was kind of considered kind of, you know, it indicates you're just a clerk or something like that. So yeah, that's a sizable thing. And in general, you know, just expanding on Janelle's thing, there's a lot of things we as developers, we know to do or we know not to do, and it gets so baked into it. I'll give you an example. We're on a website. Things are a bit slow. You press a button, you see it spinning, you know, see it reloading. Basically, we know not to press it again. You don't want to press it again. It's waiting, it's thinking, it'll be coming back. Same thing with buttons on an interface, right? We kind of know how radio buttons work. We know how to enable, you know, the other option or what have you through checkboxes. We just know how to get around things, and we know what we're not supposed to do, and we don't do it because we think it's going to yield bad results. But your average user doesn't know these things, and so they end up stumbling, and they don't know the color codes we use for things, and they don't know what it means to be grayed out. You know, the grayed out means it's disabled, and so you can't push it. They're not clued into that a lot of the time, and so they end up making mistakes that we don't make, and often those mistakes yield errors. So we had this, oh man, gosh, was it 2 or 3 years ago, by one of our products that folks were using, and just kept on having problems with it. And the issue was, it was an Android app. You'd reboot. So it was automatically running every time the phone booted up. The app would be running. It was running in the background. You could go to notifications and see it running there. There's even a little icon up in the notifications area. Now, we kept on getting reports. It was very stable for us. We kept on getting reports this thing is crashing. This thing is crashing all the time. And we were at wit's end about what's going on, until finally I had a sort of sudden realization. I noticed, wait a minute, there's an icon on this phone for this app as well. I just never press it because I know it's running. I never go to press that because why press it? It's running. I don't have to. But it turns out our users were always pressing that. They thought, okay, I want to go to the app, so I need to press that button. And it would lead to situations, maybe not every time, but maybe 1 out of every 10 times it would crash. And so, I was always going through the navigation menu, never pressing this icon again. They were always pressing the icon. They were just getting all these crashes. Sort of indicative. They're just different assumptions. So we took the icon away. It was fine. It was fine. So why do we have the icon there? Well, we thought it was harmless. It has no use, but it actually ended up getting misused by users, and it's pretty indicative. We had other cases with that same app with, it beeping, and for us it would seem like an easy thing to resolve, and not for them. So there's this notion of hallway usability testing, which is basically you grab a few people, you sit them down, you have them try out the system or get them to walk around with it for a day, and often you get enormous insights you would not have gotten if you had tested it yourself. So give that a try. Let's talk about regressions. Regressions, folks. Regressions. A regression is when a change breaks a feature operation that previously worked or that should have worked because you thought it was fixed now. Okay, so you do something, and basically this thing that should have been fixed, should have been working, no longer is, or is not. And we talk about a regression test gap being the gap between a current test set and the entire test suite that has ever been run. So the idea being that maybe we're only testing certain things that are recent, associated with recent problems, but there may be things that we should be testing for that have now failed again, but we're not testing for them because we haven't tested for that in a long time. That was fixed a long time ago, so we're not testing for it anymore, which is a big problem. So this notion of regression testing has traditionally been an area of focus for programs, not least because there is a serious danger that regressions will come up, that things that failed before will fail again. Why is that? Why might things that failed before reemerge? I think we may have talked about it in the greatest hits thing, but why might they come back? Could be a couple of reasons. Things that failed before might not now be fixed. Well, one thing I'll just throw out there as a freebie, it's kind of a case you're not thinking about, is a lot of bug fixes don't work. This is old data, but it's indicative. The bigger it is, the bigger the fix, the higher the chance it won't work. The claim here was that for bug fixes involving changes to 50 or so statements, only 20% of them actually worked. Now you could say, oh, this is off. Today's software environments, it's higher than that. Maybe it's 50% now. But the point is, it's still few. Still few that actually, many that don't fix it. Okay, you go to fix, and what are the problems here? So you got to fix a bug. How could it be you're not better off? Give me two different ways.
Reintroduce an old bug.
Yeah, you introduce another bug, or this one you thought you fixed it and you still didn't get a certain case, or didn't fix it with all the generalities, you only fixed a subset, or actually you just didn't fix it correctly after all. So, there's lots of reasons for failed fixes. I think we've all been in that situation, right? Where we try to fix something and we think it's fixed, but something else has come up, or what have you, or it's not fixed. So why do the earlier bugs reemerge? In concrete terms, why might an earlier bug come about again? Why might an earlier failure reemerge in a later version in the source code repository?
Fix it on one branch, but not another?
Good. Fix it on one branch, not another, and you merge them. Now you're back to the original code. Could that happen? Yeah, it can happen big time. Big time. You say, oh, we don't have time for this feature. Let's delay that stuff. And in there is a bug fix. There's an extended feature and a fix to this bug, and you end up, let's not do that for this version. So that the bug is still there in this version. Okay, how about another reason they might reemerge?
If you're not documenting your process, you might have, say, made a decision, maybe this type is good, and then you encounter a bug, and you say, well, let's switch to this other class or this other type.
Yeah.
And another bug comes up, and someone might say, well, what if we switch it to this other thing, not realizing that
Good.
there was a reason behind the reason for that.
That's right. That's right. So sometimes you're switching between strategies and hasn't led to really thoughtful components. So merge conflicts, accidental recycling of earlier code, inadequate propagation of information about a change between developers. I fixed it, but she doesn't know that I fixed it, and doesn't know that it needed to be fixed even. Sometimes the same misunderstanding happens twice. Or, have you ever been in that situation where you fix a bug here and you cause another one here and vice versa? It's like squeezing a balloon, it pops out somewhere else. Think you have it fixed, and it just leads to this other problem. And it goes back and forth. So, fix A, breaks B, fix B, breaks A. A's back. A's back. Right? Hope I'm not bringing back traumatic memories. Okay, so it's really valuable to try to test for existing bugs, or bugs that should be fixed. So if you find a bug through manual testing, try to create, for a lot of cases, an automated bug fix. So why does it help to create an automated an automated test for it? Why?
It happened once, it can happen again.
Happen once, happen again. You want it to be automatically checked from now on. It's part of the regression test. Make this from now on automated. So first time it was found, exploratory, fair enough, that's great. Exploratory testing is really valuable. Now turn it into something that's automated so we make sure it doesn't come back. So even if we roll back some source code, even if we decide not to ship this feature after all, even if we do source code merging, if it comes back, we'll find it as soon as possible. It's being prudent. The level of observed interactivity is limited. Okay, let's talk about defect severity. Ladies and gentlemen, let's consider a case where you're rolling out a new feature. And this new feature for a user, an end user, that it gets rolled out to doesn't work. Are they going to be happy? No, maybe they upgraded for this feature. Maybe they came to your product versus a competitor for this feature, and they're disappointed. But let me ask you this: how bad is that compared to if you've had a customer for a long time who's been using your system over the past year or what have you, woven it into their life, and then a feature they've been using all through that time suddenly fails? How bad is that? That's bad. Right? Young people probably have a way to say that. I guess you can't say it's sick anymore. Sick supposedly meant good, I was told, but then someone said it no longer means good, which is good as far as I'm concerned. Anyway, so you have key customer workflow, what they're counting on day to day is being disrupted. That's really bad. If you have an existing feature that's broken, that's bad. So if you have a regression that breaks an existing feature, that's bad news. Maybe they have documents in the software which use this feature, and now suddenly those documents no longer work. We've delivered negative value with the latest version, right? Maybe I'll write something over here for a change. That is bad. Right? Okay, so that's not a that's a very serious thing. Now, I would note that when it comes to actually testing it, there's actually a similar difficulty. So if an existing feature breaks, often it's a higher cost to detect because you're not running the regression suite. You're not looking for something there. And it's often additional time and risk to repair it. Why would it take additional time to diagnose it and repair it? This is an area of the code base you're not modifying now. You've forgotten what's there, how it works. It often requires additional kind of study. Whereas if it's a new feature, you've just developed it, it's fresh in your mind, and so you can often fix it more easily, and you can even detect it more easily. So it's, ladies and gentlemen, it's a no-brainer. These are the things that are bad. These are the things you want to prevent: breaking of existing features. So you want to have vigilance strongly against them. You want to make sure that you've got the regression tests in place to make sure these don't come back, and that you respond to them quickly with extra seriousness, because this is very bad, especially. And if this happens, it requires more work. So you've got to be very cautious about something that's going to jeopardize an existing feature. So if you're balancing, do we roll out this new feature? It could break this existing one. Be very cautious about that. Be extremely cautious about that. Breaking existing feature is very, very serious. Ladies and gentlemen, customer identified bugs. Do customers ever see bugs? Yeah. Yes, they see bugs. Yes, we see bugs, right? You need to learn from them. They're painful, they're expensive to fix often, they're embarrassing, but they're really valuable for helping us figure out where we can improve our process. How can we prevent similar problems in the future? Where are our vulnerabilities, right? May help us identify areas where other defects might lie undetected. Reasoning about how this slipped through our testing might help us develop whole new, better testing suites. Why didn't we catch it during that code review we did? These are good questions if they're asked not in an incriminating way, but in a way, what can we do to prevent these sort of things in the future to improve our processes? So again, learning from bugs to debug our processes is a big lesson here. And they can provide the basis for regression, right? But they can lead to customer alienation. Okay, ladies and gentlemen, these days, as it has been the case for at least 20 years, there's a big emphasis on beta testing. What is a beta test? How is a beta test different from a lot of the testing we talk about in this course?
It has near complete functionality on a smaller
Good.
base of real users.
Excellent. So who's conducting it? It's being conducted by whom? By real world, by people in the world. It's not just by the testers. So and why is that particularly valuable? Well, we see the software used by real world people with real world workflows, data, environments, configurations. That's really valuable. We see it in environments with firewalls in place, and we see it with environments with different needs for it, different understanding. But bear in mind, and we'll come to some trade-offs with it. This is really valuable. The feedback you get is very valuable. But you have to realize that often beta testing is more of a marketing move than a testing activity. It's getting word of mouth out, getting mind share out about what's coming, upstaging competition. It's letting partners who are building atop the system get going, getting early public reviews, getting the buzz going for your latest release. And at some levels, companies sometimes talk about it as kind of testing for free. For free in the sense that you're not paying the testers. They're seeking to get it. The downsides are that it's typically not representative users. Who are the users that do beta testing typically?
Ones that are really gung-ho about your software.
Yeah, often power users, people who have been, enthusiastic about your software. They're the folks who have used many features of it, that are really counting on it. They're not going to be representative of the newbie. They're not going to be representative of the, someone who's just seeing it for the first time. And the flip side, and this is contradictory, but there are a subclass of them that just dip their toe and they actually don't use it that heavily. They've already got an installation. They're already using the site. They try this one out a little bit just to see what it's like, and then they go back. So sometimes they don't just use it that heavily, because often they have access to the existing system. And there's a real issue that sometimes if they're turned off, if they have bad experience, they just won't give you time of day. They'll just uninstall it or not use it, and basically they don't have an obligation to you. I'm not paying them. They don't have an obligation to you to sort of give you really detailed feedback. It's hard to get good bug reports, etc., from them. And there is the risk that you may scare away some potential users here. They may say, "Oh, this new release is a dog. I'm not gonna use it. This looks really flaky," and they may tell other people that this is looking really flaky. And often developers, can't really ascertain what's going on. If you do this, if you do beta testing, alpha testing, it makes even more important this last point. Put in place instrumentation in your system to record what people are reaching. Sort of like logging, but for your average user experience, so that you get back reports as to what features they're using, how deeply they're going into it, where they had trouble, where they encountered, error messages or what have you. This is really useful. And if you're dealing with in-house testers, like you folks will for much of the term, you may get a lot of information about seeing a failure. If you're dealing with beta testers, chances are you won't without instrumentation. So get it to, at the least, post back to your server, to a RESTful interface, or an HTTP server. Have it post back reports of progress if the users will let you. Okay. I think that's all we have time for today. So it's 20 past. So I'll be coordinating with some of the teams for additional meetings. It may be that I'm trying to arrange the time for our thorough walkthrough of your products, and that should be figured out by the end of the day. So we'll be sending mail to the team project managers to let you know the timing of our bug reviews, sort of our system review session, our ID1 review session. And I'd like the project managers to nominate someone. Prior to that, it will not be before tomorrow night, maybe over the weekend or Monday. That's the latest it will be. I'd like you to nominate someone to come from your team to that session when we send mail to say we're ready, so that person can testify for things that are not clear from the report. So we could talk with them about what we see, but a lot of it is to find, we didn't see this in there, did you actually do that? Or could you clarify this issue? It's to get fair marking and fair understanding of your progress. Okay? That can be a project manager. In some ways that's ideal because it's a conduit back to the team, but it could be someone else in the team if the project manager deems it best. Okay? Thank you very much.